Hi, in this video we are going to work on sketching graphs of quadratic functions. Right, let's look at this example now. It says sketch the graph of y equals x squared minus 5x plus 4, and then we're going to find the coordinates of the turning point as well. Now, we're going to remember this when we draw the graph. So, to be able to sketch the graph, we need to find the y-intercept, meaning where the graph cuts the y-axis, and the roots of the equation x squared minus 5x plus 4 equals 0, which means where the graph cuts the x-axis, right? So, for the y-intercept, all you need to do is to go like x equals 0, x equals 0, sorry for that, and then this becomes y equals 0 squared minus 5 times 0 plus 4, so basically all these are cancelled and you end up with y being 4, and then the y-intercept coordinates will be 0 to 4, so it's going to be 1, 2, 3, 4, that's going to be my y-intercept. You don't need to show this work though, you can just write x equals 0, y equals 4, because you can directly see that the constant will be the y-intercept. For y equals 0, that's going to be x squared minus 5x plus 4 equals 0, where when you solve this, you find the roots to be 1 and 4. So the coordinates will be 1 to 0 and 4 to 0. So let's plot these. It's going to be 1 here. So this is my root. 2, 3, 4. This is my root. So I will be drawing my graph, my quadratic graph, which is a parabola, from these points. So basically, it's going to go like this. Right? And now comes the coordinates of the turning point. The turning point means this. I have to find the coordinates of this point where the graph changes direction. Alright? So let's do that. For this, I'm going to complete the expression the square. So this expression is basically x minus 5 over 2 bracket squared minus 9 over 4. Now, the turning point coordinates will be the additive inverse of this number, so it's going to be 5 over 2 for x coordinates, and exact value of this constant, minus 9 over 4, right? So this is the coordinates of the turning point. We will go deep into this when we're working on graphs of functions later on. Another example. Right, now we have here y equals minus 2x squared plus 4x plus 3. We're going to sketch the graph, find the coordinates of the turning point, and then also we're going to write the equation of the line of symmetry, because parabolas are symmetrical in general, and we have to write the line of symmetry, which would be a vertical line. We'll see how. For x equals 0, y equals 3, the reason, well, these are all gone, and we write this as coordinate, right? So I have the y-intercept to be 0 to 3, and then for y equals 0, minus 2x squared plus 4x plus 3 equals 0. Just because I'm asked to write the coordinates of the turning point as well, which I can only find by completing the square, I'm going to solve this equation by completing the square as well. So this is the equation with a complete square, and right, now at this point x plus 1 equals plus minus square root of 5 over 2. I can write this as plus minus square root of 5 over square root of 2, and then rationalizing the denominator I will have, plus minus root 10 over 2. Why? Because I'm multiplying both with root 2. Alright? So I'm going to go on with this now. So I have x being minus 1 plus minus root 10 over 2. So this means x1 will be minus 1 minus root 10 over 2, and x2 being minus 1 plus root 10 over 2. Now here, this one is a negative number, this one is a positive number, so it must be on each end of the y-axis. Right, let me just plot these points now. Now you can see the decimal values by using your calculator. I mean, what is minus 1 minus root 10 over 2 and what is minus 1 plus root 10 over 2. You can find the decimal values, and then you can decide whether it's a negative or positive number on your own like that. So that's going to be, right, it's best to have the y-axis to be moved a little bit to the right. Now that value will be very close to minus 5 over 2. So let's say it's here, all right? And, well, I'm not going to write the whole thing here, but this is where it is. And then this is going to be something like 1 over 2. Let's say it is here, right? And I have the y-intercept to be 0 to 3. So it's going to be, let's say, here. All right? So my graph will be something like this, right? It's going to be a curve. Of course, I can draw it better, I hope. No. One more try. Yes, this looks all right. Now, of course, it's easier to draw on paper and pencil, right? And this is how it looks like. And now, just because I have the complete square, I can write the turning point's coordinates as well, which would be, right, so it's going to be here, negative of that number, minus 1, and exactly the same thing to 5. So basically, that turning point will have minus 1 to 5 as the coordinates. So that's the answer to both 1 and 2 here. I wrote the turning point's coordinates, and I also sketched the graph. Now, the line of symmetry is where you just have the graph cut into 2 bits and fold it so that it's going to match. If you cut it from the red line, which is a vertical line, and fold it, this part and this part will match. And luckily, when you find the coordinates of the turning point, you also find the equation of the line of symmetry, which will be the x-coordinate of the turning point. So for this, all you have to write down is it's going to be x equals negative 1. That's the line of symmetry that you can see here, because the line of symmetry passes through the turning point. All right? So the line of symmetry will be x equals negative 1. For the sake of the video being, short, I didn't solve the completing the square or solving the equations bit step by step. I just wrote the steps, so you may need to watch the video again to understand how I solve it. And my suggestion is, please solve these examples yourself as well to end up with the same results. All right? So check whether you end up with the same results, and then move on the exercise set. Right. So there are 2 functions here. For each of them, you have to sketch its graph by finding the y-intercept and the roots. And by the way, you may find the roots with quadratic formula or some product if possible, right? That's okay. But just because we have to find the turning point, that's why I used completing the square for solving the equation, because then I used that form, that expression, complete square expression, to write the corners of the turning point easily, right? But you're free to solve them in any way, all right? So you're going to solve for the roots of the equations, right? And then you write the corners of the turning point, and then you write the equation of the line of symmetry from the x-coordinate of the turning point. So please solve these questions on your book and submit your answers, only part B and C, because you can't sketch it on the online self-check, right? So solve and submit parts B and C on online self-check. Thanks for watching.